Since prehistoric times, man has sought a better way to keep tabs on irrigation water. Working with primitive materials, early man measured water, but their efforts didn't amount to much. Over time, man succeeded, at least in sending water where he wanted it to go, one way or another. Today, man controls his irrigation water by measuring it. But how much water is enough? Too little water stresses crops and hurts yields. Too much water costs extra to apply, leaches valuable nutrients, and also reduces crop yields. But no matter how you irrigate, accurate water measurement gives you the information to manage your water and keep you out of the Stone Ages. Across the West, water is in high demand. Competing demands and water shortages caused by years of drought have reduced water supplies in many western states. As a result, water users in the agricultural sector are under pressure to become more accountable for its wise use. For this reason, the Bureau of Reclamation recommends efficient water measurement practices during all phases of water delivery and irrigation. A reliable accounting of water usage is essential whether you're an irrigation district or an individual irrigator. In this video, we'll demonstrate 4 water measurement devices used to measure water flow rates. The devices are designed to meet a wide range of water delivery system applications. So whether you're diverting into narrow concrete canals or gigantic laterals, we have a water measurement device for you. Water measurement has changed little from the early days. In fact, many irrigators still use the same system of canals, laterals, turnout structures, head gates, and weirs that their grandfathers did. Today's water user faces daily challenges to conserve water and make the most of every drop. That's why learning the proper operation of several water measurement devices is important. Our aim is to help you get a handle on the amount of water delivered into your canal system and turnouts. Let's start with some water measurement fundamentals. CFS, acre-foot, and head. CFS, or cubic foot per second, is a unit of water measurement defined as a cubic foot of water passing a fixed point in 1 second. Many recognize this as second feet. It describes the water flow rate within waterways, canals, and ditches. Acre-foot is a volume of water that will cover an acre of ground to a depth of 1 foot. Ask any ditch rider, and they'll tell you that when 1 CFS of water runs for a 24-hour period, it will accumulate 2 acre-feet. Or to put it another way, the volume in acre-feet is obtained by doubling the flow rate in CFS over a 24-hour period. What's more, acre-feet also describes the volume of water stored in a reservoir. Finally, head is the driving force that makes water flow. It is a combination of the depth of the water and the speed it travels. To measure water more accurately, we slow the water to reduce turbulence and eliminate the effect of velocity. With water speed under control, we can now determine head by measuring the depth of the water above a specified point, like this staff gauge. All of the water measuring devices featured in this video follow this principle. So remember, from here on, we'll define head as the depth of water above a specified point. Obtaining the proper head measurement is sometimes confusing, yet always critical to accurate water flow measurement. All of these water measuring devices experience head loss or head drop. This amounts to the difference in height of the water upstream and downstream of the structure. As you'll see in this video, some water measurement devices require a relatively large amount of head loss while others function with minimal head loss. Armed with these concepts, irrigators can lay the groundwork toward accurate water measurement in the field. At this demonstration site, 4 water measurement devices are in place. Each one is designed for a specific application, whether it's for concrete canals, low-head delivery systems, or high-volume laterals. These water measurement devices are the Cipolletti weir, the Yakima box, the submerged orifice, and the broad crested weir or ramp flume. Resident water expert Fred Whetstone is on hand to give us a few pointers on these popular water measuring devices.
Between you, me, and the fence post, water measurement ain't what it used to be. I've seen this weir just about everywhere, and I'm sure you have too. In concrete canals, dirt ditches, it's one of the most common devices around, the sharp-crested weir. This particular weir is a Cipolleti. You can tell because the sides slope at a 4-to-1 angle. Now, don't confuse the Cipolleti with the rectangular weir. You see, the rectangular weirs have vertical sides, yet they both do the same thing. They measure your water. All sharp-crested weirs should have a metal crest or weir blade, a stilling pool to slow the water down, and a staff gauge set level with the crest. This is a 2-foot weir. You always measure the length right here along the crest, and the crest must be level if you want an accurate measurement. Here's a textbook example of how to mount a staff gauge in the stilling pool upstream of the weir. It's also acceptable to mount the gauge alongside the weir, as long as it's away from the weir crest and out of the drawdown area. And don't forget, the staff gauge must be level with the top of this weir blade. Hey, it's me. And here we are in the lab, as you can probably tell. This is a scale model of a Cipolleti weir. And I'm just going to place this here in our water measurement model. All right, look closely, and you can see how the water travels over the weir crest. To measure this accurately, you want to make sure that the water springs clear and free of the crest, which this one looks pretty good. Now, the water level downstream should not influence the water level upstream. So if an air bubble forms below the crest, you're doing it right. If no air bubble appears, the weir blade is too low. So in the field, the weir crest should be installed at least 4 to 6 inches above the maximum downstream water surface. Out in the field, you can measure water flow by taking your staff gauge and placing it here on the crest of the weir. Now you want to measure to the point where the water boils up to. That's your measurement point. Now some folks say to hold it perpendicular, while other people say to hold it at a 45-degree angle. For this particular weir and this particular flow rate, we're going to use a 45-degree angle because it seems to match up best with the fixed gauge. Now our gauge says we have 0.42 feet of head. Let's check our tables and get the flow rate. For a 2-foot Cipolleti weir, 0.42 feet of head means 1.8 CFS is flowing. If you use the handheld staff gauge, I recommend installing a few fixed staff gauges on typical weirs to check your technique and ensure that you're getting an accurate reading. The sharp-crested weirs are relatively easy to construct and maintain. Now they catch some trash, but it's right here where you can get to it, and it's easily removed. Silt tends to settle out in the stilling pool, so make sure you clean it out as needed. Now the Cipolleti weir can also be used in large canals to measure 20 to 2,000 CFS. In some of these applications, head loss can range from 2 to 6 feet. But let's not beat around the bush. This weir requires a large head loss, in this case, about a foot. So if your land has a lot of fall or slope to it, the Cipolleti weir may be the weir for you. A lot of people call this contraption a weir in a box. Why? Well, because it's a weir in a box. That's all it is, a sharp-crested or Cipolleti weir in an enclosed box. Maybe you've seen this before as a turnout along a canal. It's got all the same equipment, level crest, vertical or angled sides, and metal faceplate. The staff gauge is installed level with the crest, away from the area of drawdown. When properly installed, an air bubble will form below the crest as water flows over it, just like a regular sharp-crested weir. But watch carefully because the strong hydraulics on the upstream side can make the staff gauge hard to read. And that's why there's a baffle placed inside to control the turbulence. The Yakima box may lose a small amount of accuracy because of the small confining stilling pool, but it's sure easy to construct and install. Heck, you can build one right in your own shop. So, what do you say we pour on the water and see what happens? Just like a sharp-crested weir, water flows over the crest. But the water's flowing pretty fast and rough right now, so I'm just going to place a baffle in here to kind of smooth it out and slow it down. That way the proper head is achieved. Once it's calm, I can read the gauge. The air bubble appears right below the crest, indicating the upstream water is unaffected by the downstream water surface. Once again, look to the table and you'll see that for a 2-foot Cipolletti weir at 0.52 feet on the gauge, we get 2.5 CFS. The Yakima box is one neat package. It's easy to use like a Cipolletti and easy to install. In fact, you can make one right in your own yard. All it takes is a little concrete and some rebar. This weir in a box causes a relatively large amount of head loss, between 6 and 24 inches. So if your system has a lot of steep grades or fall at the turnouts, the Yakima box is perfect for you. Let's take a look at the submerged orifice. It's a device so simple, you'll wonder how you ever got along without it. Why? Because it requires a minimal amount of head loss, and the flow rate can be adjusted right at the structure. You've probably seen it used as a turnout gate because they work great in ditches with flat grades. Let's take a closer look. A submerged orifice has two parts, a rectangular opening and a control gate. The size of the opening depends on how much water you want to run through it. The opening has a metal faceplate with a horizontal top and bottom and vertical sides. It should be wider than it is tall. This opening is 6 inches by 24 inches, or 1 square foot. The opening should also be raised up from the bottom of the canal and centered in the wall to allow the water to approach it from all sides evenly. All right, we're back in the lab. And I have here a scale model of a submerged orifice. So we'll just slide this into our channel. Now remember, operation of the submerged orifice is dependent on knowing the head differential or head loss. It's easy to determine this if you install two staff gauges, one upstream of the opening and the other one downstream. Now when the staff gauge is set at the same elevation, subtract the downstream gauge from the reading of the upstream gauge. That number is the head loss for this structure. Okay, once you know head loss, just check it against a table for this size opening and find your flow rate. All right, let's go back to the field and we'll do an actual measurement. If the opening has been sized correctly, the range of flow rates to be measured will cause about a 0.1 to 0.5 foot head loss. If you know the desired flow rate, simply look at the table to determine the required head loss and adjust the back gate until the head loss is reached. For example, this opening is 1 square foot. Using this table, we can easily determine that with a 1 square foot opening and a 0.17 foot head differential, that the flow rate through the device is 2.0 CFS. In some cases, the size of the opening is adjustable. This works really well when there's a wide range of flows that are diverted through the same gate. Now, be sure to accurately measure the area of the opening when figuring your flow rate. Well, it looks like we've saved the best for last. This is one of the most innovative and unusual weirs that I've ever seen. This is what we call a broad-crested weir, or it's also called a ramp flume. A broad-crested weir is just a ramp that leads up to a level crest. It can be easily installed in canals and ditches with concrete lining, and can also be constructed in unlined canals. Best of all, broad-crested weirs have minimal head loss and are very accurate. The beauty of this design is its simplicity. Basically, all broad-crested weirs have a ramp and a sill. They can be made of concrete, sheet metal, or steel. Out here we have a sheet metal broad-crested weir in 3 different sizes to match this particular ditch. Based on computer design, broad-crested weirs can be tailored to fit the specific flow conditions of your canal. Once installed, the as-built dimensions are measured and used to make the final rating table. This way, minor construction flaws do not affect accuracy. A staff gauge is mounted a specified distance upstream, and it should be level with the crest. The slope of this staff gauge has been factored into the flow table. We're back in the lab. And I'm here with the scale model of a broad-crested weir. Let's check it out. The broad-crested weir is great, and you know why? It's simple. For starters, there's no stilling pool here because the approach velocity is not as critical as with other devices. Now, when water flows over the ramp, it accelerates and contracts. Then below the weir, the water slows, then expands. You want to look for this contraction in the water's surface to indicate that the broad-crested weir is measuring accurately. But when I tweak the downstream water level and flood out the broad-crested weir, the contraction and expansion pattern disappears. When this occurs, your measurements are basically a wash. No pun intended. So let's go back out to the demo site and go figure our flow rate. With water flowing in the ditch, you can see our gauge is reading 0.47 feet. Now convert this reading to a flow rate using the computer-generated flow table designed specifically for this 9-inch broad-crested weir. In this case, the table indicates that with a gauge height of 0.47 feet, the flow rate is 1.6 CFS. And check out the head loss. It's minimal, only about 4 inches. This weir can be used in many places where there's little available head loss. Broad-crested weirs have been installed in main canals of over 1,000 CFS. If designed properly, the head loss at high flow rates can be less than 1 foot. To top it off, broad-crested weirs are self-cleaning. They sweep themselves clear of silt and trash. So for low maintenance, low cost, and minimal head loss, the broad-crested weir may be the best thing for your water delivery system. Whether you select a submerged orifice, a Sippoletti weir, a Yakima box, or a broad-crested weir for your water measurement needs, each device will deliver accuracy you can count on without adding expensive maintenance and operation costs. And while head loss ranges from small to large, an accurate water measurement device can be matched to specific needs of your delivery system. If upgrading your water measurement device is important to your operation, remember that accurate water measurement means improved water management. Using these valuable time-saving water measuring devices may change the way you do business and lift your operation out of the Stone Age. For more information on any of these water measuring devices, just contact the Bureau of Reclamation office in your area.